discuss that. But yeah, today's focus for us is actually on water chemistry. Correct. So you mentioned a couple of things related to that. That if you don't maintain the water chemistry, a simple issue like scaling can have detrimental effects over not only the life of the equipment but also its performance, which continues to deteriorate over time. Yeah. So I want to deep dive into this. So how best do you think we are looking at water chemistry? What are the current situations?
So if you see, as I mentioned, that over the years, this Rankine cycle is developed a lot. Boilers becomes advanced and everything. But at the same time, to increase this efficiency and everything, we are using lot of different kind of boilers, either fire tube or water tube boilers, and water necessary pass through very narrow areas where heat is transferred to it and it's converted into steam. So main issues can be either on a fuel side or where you are at a gate, or on water side. Okay, for any boiler or any steam generator, whether it's a nuclear power plant or whether it's a small process boiler. Everywhere you are transferring heat from a flue gases or hot gases or any heat source to water, and that side, water side scaling and water side issues are also very can impact overall uptime, life cycle, and also efficiency of this cycle. So talking about water side issues, because today our session is focused around that. So if you focus on a water side issues, there are two main issues. Main is related with the depositions. So we say in scaling in our normal language. So scaling of the boiler parts or water side parts, and second is the corrosion related issue. Okay, so corrosion and deposition, I could say these are two main issues in a heat exchange in boiler or in Rankine cycle or steam water cycle. Third issue raised as a result of it, that when there is a corrosion and when there is some products like oxides, they start flowing in this cycle and they start eroding. Right. So there is a erosion comes as the next stage. Corrosion, erosion, and deposition are three main issues, I would say, in steam water cycle. Yeah. And that's why you need to monitor this entire steam water cycle very, very precisely, and you need to have some corrective action in terms of how you can reduce this effect of corrosion and deposition, how you can avoid it. So there are a lot of other auxiliaries are added. So we have some dosing chemicals. So we try to maintain pH in entire cycle on alkaline side between 8.5 to 9.8, which is right. Because in acidic environment, always metal corrodes a lot. Yeah. Okay, there is a corrosion attack. So we try to maintain pH on alkaline side. We try to reduce as many dissolved impurities in water, because these impurities, if these are like hardness causing salts like calcium carbonate, magnesium carbonate, or even silicates, phosphates, these can deposit. So that related issues we can reduce if we can remove the salts right in a field water before going in a boiler, or you can want to reduce corrosion causing salts like chlorides, and sulfates like that. So by treating water and maintaining its purity entire cycle, we can actually ensure that this cycle keep working with the desired thermal efficiency, the desired mechanical efficiencies, and also it is available always. Means if there is no failure of any equipment in this cycle, and which can lead to catastrophic failure. Also, it relates with the safety of the equipment, because as you know, we are talking about increasing efficiency and increasing pressure in a boilers or a steam generation. But when you increase pressures, so today ultra-supercritical boilers are operating at the pressure as high as 300 bar and 600 degrees Celsius. So at that pressure and temperature, metals are also more in stress condition. Yeah. Though there can be issues related with the creep strength, there can be issues with the fatigue failure and stress corrosion. So all these kind of issues, I would say, amplify when you expose materials under high pressure and temperature. So steam purity and feed water or steam water cycle purity becomes a very paramount importance for operators who are operating these power plants.
Yeah, that's a very interesting way to look at it. And the way we talked about earlier in terms of the evolution of technology, it is after all working since last 200 years. But if you remember the earlier locomotive engines, they used to just take the water at every railway station. At least that was the case in India. I'm not sure how it works in the West. But the earliest models used to simply pumping fresh groundwater into the boiler, and that would significantly reduce the boiler life. So eventually that engine is going to go through. There were pressure limitations, obviously, the way you talked about. The combustion was by no means monitored or regulated in any way. But since then, if we look at right now, the kind of water chemistry you're talking about almost always necessitates a closed loop, right?
Yeah.
Because we don't really want any of the water simply being dumped, the way the locomotives used to simply dump steam, exhausted steam. We don't want to do that.
Correct.
But this is now a closed loop where purity becomes an ultra-important concern.
So if you talked about today's Rankine cycle, I would say it's the most ideal in terms of condensate recovery.
Right.
So once using a steam on a steam turbine, it is taken to condensers, either water-cooled or air-cooled condensers, and where it's condensed and pumped back. By doing that, we actually take care of huge water, or pure water, I would say, ultra-pure water is recycled back to process,
All right.
back to boiler as a boiler feed water, and it's revolved once again. But even in that scenario, smallest leakages or smallest seepages in this cycle can contaminate this entire steam cycle. And that's why there is it's very, very essential to monitor this steam purity, feed water purity, drum water, and condensate. These 4 areas, I would say, very, very accurately. And also you need to implement some controls on chemistry, like there are some dosing of the chemicals to take care of pH and to reduce corrosion issues. There are some actions like a deaeration you need to take care, where you need to remove dissolved gases like dissolved oxygen, which actually result in oxidation of the metals. And similarly, a lot of other things we implement in entire process.
Yeah, okay. But I mean, I understand this.